Good evening, everyone. Can you all hear me?
Good evening, Bona.
Good evening.
Good evening.
Oh,
Yeah. So today we'll be diving into introduction to software testing, right? So we have talked about Agile and Scrum, getting to know our computer. So today we'll be talking about software testing, right? So we'll start the introduction. We'll start with the introduction of software testing. So let's dive into it. So our table of content. So we'll have the background of testing. Yes, we'll be discussing about the background of testing. We'll be talking about what is software testing. It's because we are going to be, we are already working as software testers, right? So it's important to know exactly what we're doing. We will also discuss why testing is important, the general principle of testing, fundamental of testing, different roles in software testing, skills of a software tester. Then we can now go to our question and answer. So the first one we'll talk about is, one second. So yeah, so the first one we'll talk about is background of testing, right? So what is testing? Right? So it's important to discuss what testing is. So testing is a crucial process that involves the evaluation and validation of a software product to ensure it meets specific requirements and function as expected. So once you have a piece of software or you have it could be hardware, it could be anything that you are given to, and you want to test it, right? You are ensuring, you are evaluating, your work is to evaluate that particular object. It could be hardware, it could be software. You evaluate it. After evaluating it, you will now validate that that particular product has met the specific requirement. Let's say they gave you that product and they say this product should be functioning in a particular way, right? So your job as a tester is to evaluate that particular product, right? And then validate if that particular product is functioning the way it's meant to function, right? So the way it's meant to function is what is called the expected results, right? So you need to understand that the expected result meets the actual result. The actual result is what you as a tester has seen it to be, what you feel, what you have seen that the way it's operating. That is the actual result, right? So you want to ensure that this actual result has met the expected, is the same or equal to the expected result. So once that is done, you can now say, yeah, this software has been tested and has met the requirement that was stated. So we'll take few scenarios. I will try and make this as interactive as possible, because when it's interactive, we'll get your thoughts or what you think, and then we will make the class interactive and ensure that it's not boring. So the next slide we'll be talking about which is a scenario one. So imagine you are baking a cake, right? So you can see the beautiful cake. I'm sure some of us are salivating already. So you can imagine you are baking a cake. So you are making this cake, right? You are baking this cake, right? So after baking it, before you serve it to your guest, what will you do first? Do you just bake the cake and bring it out and then give it to your guest to eat? What do you do before you actually serve it to your guest? Any option?
You have to test it before serving it to your guest.
Good, good. Any other, you have to test it, I agree. So why testing it? What are you looking out for?
You are looking at the best, like you're going to make sure that everything is complete, the ingredients, the quality, just general making sure the cake is standard.
Yes. Yeah. Any other, well done, Joshua, that's a good one. Any other opinion? Does anyone have any other input?
Yeah, just making sure that it's presentable.
Yeah.
And everything is at the normal level. There's no much sugar in it. There's no much butter in it. Actually, you're making sure that it's eatable.
Yes. Beautiful. That's a nice one. Yes, that's correct. Yes. Any other person?
while baking the cake or when you want to serve it,
Yeah.
it's not enough to just check to see if it tastes nice or if what the ingredients are all at equal proportion or the right proportion. It also extends to how you're going to serve it, how you're going to package it, which kind of plate you're going to give it. So all these things involve testing too. Thank you.
Perfect. Excellent. Great. That's a nice one. Yes, I'm liking the input. Casey, have you got any input to make?
Yeah, I guess I don't know, it's sort of kind of echoing what others have said, but obviously you have to test that the cake is okay, but also you have to make sure that the cake serves the guest is meant to serve. For example, say you have guests who like vanilla cake or other cake, so you have to make sure that your cake is specific to the guest request. Yeah.
Yes, absolutely. That's correct. So you are all correct. So before you serve the cake, you need to test it. Jisha mentioned it. And how do you test it? Right? You check the physical look to ensure that it's perfect, right? You ensure that the icing on the cake is perfect. You ensure that the color of the cake is what the guest wanted. Let's say the guest has, requested for a cream cake, right? So let's say the guest has requested for a cream cake. So you want to ensure that the color of the cake is cream. They've requested a particular style of icing. You want to ensure that that particular kind of icing is what you've made the cake with, right? They've requested for a particular kind of, a particular kind of color. Yeah, I've mentioned color. I've mentioned icing and design as well. If they want a round cake, if they want a love shape cake, right? You need to ensure that that is exactly what you are giving them, right? And how you do that after baking, how you do that is to test it to ensure that all the requirement, that is the requirement we are talking about. All the requirement that they've given you is what it is. So the actual results has met the expected results. So that is what testing is all about. So if I go on the next slide, like I said, right? So before serving to the guest, you make sure that it tastes delicious. You've mentioned it, that is correct. It looks perfect, which is the look, right? And then you check that this texture and see if it's cooked through, right? You don't want to serve your guest with uncooked or cake that is not baked properly. So when you are doing all these things, it's testing. So testing is what you do in every day of your life, right? You do testing every day. That's why testing is one of the easier professions to get into, because it's something that you practice every day of your life. So, but sometimes we do it without knowing that we're actually testing, right? But we are testing. So once you have this experience, right, every day of your life. So it's when you are bringing it into the industry, like you're testing software or you're testing a hardware application or anything, you will be very good at it, right? So let's take another scenario, right? So I know most of us, has gone to bought a car, and yeah, you already know what you do before you actually pay for the car. But I would, let you say what you do. Let's say, imagine you are buying a car from a showroom, right? So before you take the car home, what are your expectations of the car? What are you expecting from the car? Any input? Okay, I think I might be calling names. Chidi, do you want to give us an input?
So if I'm buying a car, I'll just check that all the parameters are there. I'll verify that tires are good.
Great.
Not flat.
Nice one.
The radio is functioning very well.
Absolutely.
The light is functioning very well. You can put the key and you start your car, or you can use the button to start your car. It's working very well. I just make sure that everything is okay before I take my car home.
Great. Absolutely. You nailed it, JD. You nailed it. So the reason why I use car as a scenario is that actually, before you take your car home, there are so many things you want to check, you want to test to ensure they are working properly. So you've mentioned most of the important things that you will want to check and have a look at before taking the car home. Joshua, do you have any other input to make? Joshua, are you there? Okay, so I think Joshua.
Yeah, I'm here. Can you hear me?
Yes, I can hear you now.
Okay, just like what Chidi said, if I'm buying it or getting any car, I will go ahead and check the engine capacity to make sure that, you know, what I saw in the paper is exactly what it represents.
Yeah.
Then just check other small basic things, just like Chidi said, check the tire, check the battery, you know, check the brake, just basically run a complete check of the car to see if what they said the car is and the functionality they mentioned in the manual is actually what it represents or what the car is. So that's it for me.
Yes, absolutely. So that is it. You are both correct, right? You are both correct. So the other things you might also want to have a look at is the body. You want to ensure that, you know, it does not have any scratches. So you go around because you don't want to go with a car that has scratches around it. You also want to also check that all the pre-sales check are complete and pass at factory. You want to ensure that it has MOT and all those things. You should be in the correct color. Let's say you are going for a black color car. You want to ensure that, yeah, you've checked it and ensure that the color of the car is red, is black, basically. So that is how it is. You also go on a test drive. Very important. I know before you get a car, before you take it home, you want to, go on a test drive to make sure that you are satisfied with the car, right? So these are all the checks, or some of the checks. I think there are many more, right? You can also do. You can also check to ensure that those tests, the car has, passed or meet your expectation. So in this case, you are the user, right? Because you are actually buying the car, you want to make sure that the actual results, right, meet your expectation, which is your expected results, right? So, so, so all this you are doing are testing. I can even give you more example. The lists are endless, right? So when you are talking about, scenarios where you do testing, they are endless. I can go on and on and on. Take, for example, the normal one that we do, right? Which is cooking. So when you are cooking, you ensure that the salt is okay, you ensure that all the ingredients, the oil, everything you are putting, you want to, at every stage you are testing it, you're ensuring that, yeah, you also test it to ensure that it's properly cooked, right? So these are these are testing that you are doing, right? In everything that you do in life, you do testing. So similarly in any project, right? So I will go to the next screen. So similarly, in every project or software, testing helps to make sure that everything works correctly and meets expectation, right? For example, if you are in an e-commerce website, right? You want to buy a product. Firstly, you want to be able to search for the product, right? Let's say you are in Amazon and you want to buy a TV, for example. You want to navigate to Amazon, right? You want to be able to search for that TV, right? And you want to see it, right? You want to be able to view the product and ensure that it's the right product that you want to buy, right? So and you want to be able to add it to cart because once you viewed it has met your expectation. It is what you want. The inches, you've seen the inches, you've seen the make and everything, right? The next thing you want to do is to add it to cart, right? And you want to click, when you've added it to cart, you want to click on checkout and you want to add your details, which is your bank statement, your name, your address, if that TV is going to be delivered to you, right? So as a tester, you will test to ensure that all these processes are working as expected, right? So the first scenario I think is you as a user going into it to ensure that you're able to search for the product, you're able to add it to cart, you're able to pay, you're able to enter your detail, you're able to pay. But what you do as a tester, you want to ensure that this journey that a user is taking, right, to buy this product, starting from navigating to the website, going into searching for the product, going to adding the product, viewing the information of the product, and then adding it to your cart. You will test all these things. To ensure that they have met the expectation, and that when customer or when a customer is going through it, the customer will be able to also go through this process, right, and successfully purchase and buy the product they want to buy. That is what you are doing as a tester. You ensure, because the customer, before the application goes live, it is your duty to ensure that whatever that will cause issue for the customer not to purchase that product, that you have tested that product, you've gone through that process and verify if it is seamless, if it is working as expected, if the customer will go through that process with ease, right? So bringing it down to PrimeSoft, right? So you went through the process, you registered, you purchased the course and all these things. So in this internship, we already have a project, right? So once these user stories and acceptance criteria have been written, so before, like as you know, we want to enhance PrimeSoft. We want to enhance PrimeSoft. So before doing the enhancements of PrimeSoft, right, we'll have to actually test it, because real users are going to be using it, right? We'll test it properly. We will ensure that whatever process that the real user will go through, you will go through it as a tester, and you will ensure that it's seamless and it has met its expected results, right? So if you have any question, pop it in the chat. I will see that and I will answer your question. Or you could jot your question down and then ask me at the end, right? So next, we are now bringing it down to software testing, right? So we've been talking about testing in general, right? We've been talking about testing your cake and testing your food and testing your car and testing other things in general. But we are software testers, so we'll have to bring it down to what software testing is, which is not different, right, from what we're talking about when you are testing things in general. But in this case, we are bringing it down or drilling it down to software, right? So what is software testing, right? So software testing is a systematic process of evaluating a software application. Note, systematic process of evaluating a software application or system, right? To identify and rectify any defects, errors, or discrepancy between the expected and the actual outcome, right? So, I've mentioned before that I've said it over and over again that once you are testing anything, you need to make sure that the expected has matched the actual. And I've gone ahead to explain what the actual result is. The actual result, I'll reiterate that the actual result is what you as a tester has seen it to be. The expected result is what the stakeholders want that piece of application or piece of software to be, right? So once what you as a software tester has seen it, to be, if is the same with what the stakeholder wants, then that particular software has passed. But if the actual result, which is what you as a tester has seen it to be, is not what the stakeholder or what is in the requirement, right, that software has not passed. So there could be a defect, it could be an error, all right, or a mistake, right? So we'll go through all these things. But once it hasn't matched the expected result, that means there is a bug in that system. Right? Is that clear? So we'll go to the next slide, which is what can be tested. Like I said, anything actually can be tested, right? But in software testing or as a test analyst, right? So you are either testing a hardware or a software. Some of you will go out there and then get into industries that will be your main job will be testing a hardware application. It could be testing TV, it could be testing Internet of Things, iOS, IoT, which is Internet of Things, right? So it could be embedded device, it could be anything. Those are hardwares, right? It could be desktop, it could be mobile phones, it could be computer games. Those are hardwares, right? So you are testing the physical hardware, right? So there are other one that you can test as well, which is softwares, right? So software could be, it could be web application, website, it could be mobile application, it could be desktop application, it could be any application. Example, like YouTube, Facebook, so those are softwares, right? You as a tester, you are also testing those things. And what are you testing? What are you testing? When you are testing it, what are you ensuring? So you want to ensure that their quality and reliability and functionality are what the stakeholders or what the requirement has stated it to be, right? So once you are testing it, you go through all the parts, all the aspects of the software that you are expected to test, right? So because we work in an agile scrum, right? So unless we are doing other kind of testing, but when you are testing according to what is in your requirement, you go through it and you ensure that their quality are what is expected it to be, their reliability is what is expected it to be, and their functionality meet what it's expected it to be and exactly what is on the requirement, right? So from there, we'll go to how can software be tested, right? So you can see the way I'm drilling it down. Like I said, we're going through the overview, which is the background, the fundamental. We are bringing it to what testing is all about. From there, we'll give different scenarios where we do testing. I want you to understand everything that I'm saying, because this could be asked in an interview. Your stakeholders ask you, I can remember in where I used to work, right? So the stakeholders, they didn't understand what my role actually is. They were so curious. They want to know what I'm doing, right? So you should be able to explain these things to them, right? So that's why I am gradually, throwing it down, going through it one after the other to ensure that you understand it and you follow it in synchron, in order, right? So we've mentioned the scenarios, we've mentioned what software testing is, we've mentioned what can be tested, right? Now we are going into how can software be tested, right? So as you know, we'll have manual testing and we'll have automated testing. So manual testing is when you are actually going through the software application, right? You've logged into the software application and you are actually clicking on it, navigating through it, ensuring that it has met the requirement or the expected outcome. That is manual testing. You are manually doing it. Obviously, you have to write your test cases. You have to do your test plan. We'll come into all these things in great details. How to write your test cases, how to design your test plan. Your test strategies, and every other thing will come into that. But once you've done all these things and you are logging into the software or the application and you are clicking on it, right? Doing it, navigating it as if you are the real user. That is you testing. That is you doing a manual testing on it because you are manually doing it, right? Whereas when you come to the other one, which is the automated test, you're now writing codes, right, that will navigate to these softwares and still perform the exact action that you as a user are doing when you are manually testing it. So of course, you have your framework that you can use when you are doing your automated testing, right? There are different frameworks you can use. You can use different programming language, such as C#, Java, Python, and so many other ones, right? So, but in the course of this program, will be learning C#, we'll be using C#, SpecFlow, and to do our automated test, which you will get to understand, right? So going to reiterate what I've said, manual testing, you are doing it manually. You go in, you log into the website, you perform you go through, your test cases, you click, you fill in, all the fields that you are. Take for instance, you want to test a login functionality, right? So when you are performing your manual testing, what do? You navigate to the website, right? You click on the login button, right? You enter your username, you enter your password, and then you click on login, right? You've logged in. And when you've done that successfully, you've tested the website. And how have you done that? You've done it manually, right? So then again, when you have written a code, right, that will navigate to the website, that will click on the login button, probably on the header of the page or header menu, right, on the menu of the page, and then you've entered using a code to send your username and your password, right? You are using a code to send it, and you're not using code, right? You've written code that will send your username and your password, and you've written a code that will also click on the login button, and you've written a code that will validate or assert that the website you've logged into the website. That is automated test, right? I believe that is clear on that. So we'll move ahead to why do we test, right? So we'll go to why do we test. So there are several reasons why we test. So many reasons why we as software testers do testing, right? So but I will mention some of the most important ones, which are to ensure quality, for quality assurance. Ensure quality assurance, they are the same, right? So testing is a fundamental component of quality assurance. So you cannot assure that a particular piece of software has met its expected results, right, without actually testing it. And when you have tested, you can now assure that this quality of the software has been met, right? That is just all it is, right? It's very simple and straightforward, right? So, like I said before, Testing is a fundamental component of quality assurance, aiming to deliver a software product that meets specific requirements, functions as intended or as expected, and is of high quality. That's what testing helps us to do. And when this particular piece of software has been tested properly, right, you can ensure it has met it's of high quality, has met its expected result. And therefore, you can say that, yeah, the quality of this software has been achieved, right? So what is the other reason why we test? Bug detection and correction, right? So software testing help identify and rectify defects or bugs in the software. This ensures that the final product is free from critical errors that could affect its performance or user experience. So when you are testing it, you are testing it to see if there is any bug. So there is no piece of software that is free from bug, right? You can't say, that's why they say there's error fallacy. So you can't say that there's no bug, that no software is bug free, right? So every software must have one bug or the other. So it depends on the risk appetite. It depends on the risk, right? It depends on the priority. It could be a bug, but it's not a showstopper. It doesn't stop anything. So the organization might say, oh, okay, that's fine. Our risk appetite is high enough to accept this bug, right? So, but what you as a tester does, or what testing help us to do, is to dictate, to test that particular software to ensure that we rectify any form of defect or bug in that software, right? And to ensure that it is corrected, fixed, and the software is functioning as expected. That is one of the reasons why we test, right? So another one is customer confidence and satisfaction. I'm not sure if you have been, in any a software or application. Maybe you are trying to log in. You are sure that you have your username is correct, and your password is correct, and you are trying to still log in and it's not letting you, right? How would you feel? You can feel frustrated, right? You could feel that if you have an alternative, company that does the same thing, you want to move over to them. Why? Because you are not satisfied, right? You've lost confidence on that particular piece of software, right? So drilling it home, let's say we are shopping in Amazon, for example, right? And once you go to a particular section, you want to search for a particular product, right? You've searched that particular product, it's not coming up. You are not seeing that product, right? But the product is there. Simply because, their search functionality is not functioning properly. You could get frustrated, right? Or you have, you've registered for, a company that just give you a particular kind of information that is useful, that you use in everyday life. So we have two, company, right? And one is frustrating you. What do? You easily move over to the other one that give the same service, that the functionality on the website, the software is seamless. You can easily go there, get whatever you want to get all the information you want to get, and use it for whatever you want to use it for. So you as a tester, you are testing that particular website to ensure that once customer has gone, you've going through that customer journey. You've gone through it, you ensure that nothing is frustrating you, you ensure that nothing is hindering you, nothing is, stopping you from moving to the next feature or to perform what action you want to perform. So if you as a tester, you are going through this website and you are frustrated, it's a bug. You have to raise it immediately, because you don't want your customer, all right, or the users of your website to actually feel that frustration. So when you have tested this particular software properly, right, it's seamless, it's not frustrating you as a tester, you will now know and be reassured that when customer goes into that particular website and they are, trying to purchase a product or trying to use your services, that it wouldn't frustrate them, that they will be confident on that particular software, right? And they'll be satisfied. That is one of the reasons why we test, right? So I will give you, for example, what happened, real life scenario now, what happened before we started, right? We weren't able to, the breakout room has been, created, but wasn't tested if someone who is not a host or an admin is able to log in. What happened? When you tried to log in, you weren't able to do that because he wasn't tested. Do you get what I'm saying? So if he was tested before asking everyone to join, right, you will realize that it wasn't that someone who is not a host couldn't join the breakout room by themselves, right? That will be corrected before asking the users to use it. So that is what testing is. Testing is very important because it guarantees, customer confidence, right? So the next one is risk mitigation. Testing helps identify testing helps identify and mitigate risks associated to the software, such as security vulnerability, performance bottleneck, and capability issues, right? So let's say a website, right, or an application, right? So they want this application is we want to open this application for users, right, to start using it, right? And then the organization is expecting that in a day, 1,000 users will log into that particular website every day, all right, or in every 2 to 3 minutes, 1,000 users will be logging into that website. And it hasn't been tested if 1,000 users can actually log into that website at a particular time, and it was rolled out. What happened? There could be risk. There could be risk that we'll have something like users trying to log in but not able to log in. I'm sure we'll experience that in one way or the other. All right. So I give you this example. There's a time where a job, this particular ministry, right, will open up a job application. So they will be announcing this job application for a very long time. Right, they are opening this job site. Look at that on the 28th. Let's, for example, that on the 28th of December, this particular website will be open to take job application. Right. So now, when they must have done, if they have done their, check, right, they would notice that because they've been announcing this every day, that they will be expecting like 20,000 or 30,000 applicants in about 10 or 10 minutes, for example, right? They haven't tested it properly. So once they have rolled out this application and the website is open to take application, a lot of users will be going into that particular website to register at a particular time, right? And what happens? It becomes very difficult, thereby risking people from actually registering, right? So people can register. But if this particular website has been tested, so you will find out that 20,000 users can use it at the same time. But now the developers will now work on it to make it more robust, to enable 20 users to log in at the same time or to register at the same time, thereby removing or mitigating the risk associated with denial of service or not allowing users to enjoy register. So it could be in every aspect of life. Imagine Facebook is not robust enough to carry to host the number of users. It will break down and people will be frustrated. So that's how it is. So testing ensure that risk of software not functioning as it's meant to function are being removed. So there are other reasons why we test, such as compliance with regulations, right? So some software, not all, has a particular regulations or requirement to comply with, right? So you need to test to ensure that that software is in compliance with that particular rules or regulation, right? I've mentioned user satisfaction, cost saving, right? Cost saving. So a lot of people think that, especially some stakeholders or some company owners who doesn't understand, maybe they understand, some of them are ignorant. So they feel like, why are we testing? We don't actually need to test, and we are spending a lot of money in testing, right? Without actually understanding that testing saves costs, right? So when a tester has detected bug, right, and is fixed before that particular feature or product goes live, right, you are actually saving money. Okay, let's take, for example, that particular software maybe registration functionality is not functioning, and you rolled it out, and users are not able to register. What is going to happen? The company will be losing money, right? The company will be losing money, and then it will cost the company more money to go and fix that particular functionality in retrospective, right? It costs them more money to fix it, to retrospectively fix it, right? So that is how it is. Say 3Mobile, for example, we are not able to top up, right? Because there's a functionality in their software or their system that enable users to top up their mobile. Let's say that particular system failed and their users are not being able to top up. What is going to happen to that organization? They will be losing money every second. That's why it's important that every piece of software, every functionality is properly tested, right, to save costs, right? So testing provides feedback. It provides feedback on the software development process. So when this software is being developed, The developers are building these particular softwares. The BAs are writing stories. The developers are building it. What does testing do? Testing provide feedback. So testing will come back and say, oh yeah, I've tested this particular functionality. Yes, the information there is correct. Yeah, I've tested this other functionality. The header menu, all the menu item that is meant to be there are there, on the footer, all the information that are meant to be there are there, on any form, all the mandatory field are mandatory, and we can't fill that particular form without filling all those mandatory fields. Do you know what I'm saying? If you have postcode validation, you test that the postcode validation, is not taking any, let's say, for example, they want that particular field, which is a postcode field, to only take UK postcode, right? You as a tester, what would you do? You will put UK postcode. You ensure that, yes, it's taking UK postcode. It's validating that this postcode is correct, right? So what do you also do? You also do a negative testing to check if someone puts a non-UK postcode, if it will take it. Let's say you put a postcode of Spain or Germany to see if it will take it. If it takes it, it's a bug because it's not supposed to take any other postcode that is not UK. So you will also, using your analytical skills, to check or look for a postcode that looks like a UK postcode, but it's not a valid UK postcode, right? And check if it would accept it. If it does accept it, it's an error, right? You provide feedback to the development team. You say, yeah, this particular functionality or this particular area, this particular field is not functioning as required, right? So what the developer would do, you know how you do that, you raise the bug. What the developer would do is the developer goes back and then look at the code, rewrite it, do their own testing, and bring it back to you to also do your own retesting. You will retest it. If it has passed good, you do a regression testing around all the website to see that the changes that the developer has done has not broken any other thing. So once you have tested that, you've done your regression test, you've done everything, and it's passed. Provided, yes, this particular software has passed, it goes live, right? And then you move into another stage of the developer move into another stage of developing, you move into another stage of testing. So testing helps to provide feedback. Right? It allows for continuous improvement by identifying areas to enhance and optimize in both the development and testing process. Right? So testing provides continuous improvement. Just like I've said, using the same scenario that I've mentioned, you test. If it's working, that's good. If it's not working, you go back to the developer. You say, yeah, this particular side is not working because you've raised a bug. That's how you do it. Yeah. So the developer goes back, tests it, see if that particular one is working. If it's not, he fixes it, and then you retest it, and that's it. You are constantly or continuously improving and optimizing the process, right? So in summary, software testing is crucial for delivering a reliable, high quality product that meets user expectation, right? Just like we mentioned in our show that when you want to buy a car, you need to test it, you need to check and look at all, the body, the engine, you drive it, you want to ensure that it has met your expectation, because you are going with an expectation, right? So let's say you are going with an expectation to buy a car that has scratch or dent, but that's your expectation, right? It has an issue, but that's your expectation, right? You take it, no issue. But if you want it to be dent, let's say some people that buy a dented car that has they've told you that it has dents on one side, and you've gone and it has dents in two sides. You don't want to buy a car that has dents in two sides. You wouldn't buy it because it hasn't met your expectation, right? So that is what testing helps us to do, right? It helps us to ensure that software are of high quality standard and has met our expectation, right? And that particular software has complied with the requirements and operates effectively in various conditions. Right? So it is essential. It is an essential practice that contributes. Software testing is an essential practice that contributes to overall success of software development projects. You will hardly, I think, I've forgotten who mentioned that there is a time that, a developer did, I think it was Elo, I've forgotten, that said that, a particular software was built, and then when it went live, they started, coming after the developer. And why was that? Because it could be because that particular software, they haven't followed the proper software development process, ensure that the software, the requirement is fully scoped out, ensure that it's designed, it's developed, it's tested. So maybe they just call the developer, just build us this is how we want it to be. The developer go off, after building it, the developer deployed it, and then they're coming after him, right? But if it was duly tested, the reason why they're coming after him would have been dictated earlier, would have been tested, dictated, fixed before deploying it live, and there wouldn't be any issue of coming after the developer or any sort, right? So if you have any question, just raise your hand. I will see your hand, and then I will allow you to ask your question. right? So that is testing in general, or software testing in general. I have mentioned that once the expected condition, the actual condition hasn't met the expected condition, that means there could be an error, there could be a defect, it could be failure, right? So once the expected condition didn't meet the actual condition, there is an error, or you can say that there is a bug in that particular software. So the next thing we'll be looking at is, what is this error? What is this defect? And what is failure, right? So that brings us to our next slide, which says error, defects, and failure. Going back to the buying of car and actually testing it out and all that, right? So when you are going with an expected condition, you're going that the car should have a red color, right? And you've gone and the vendor told you, oh, this is your car. And you're looking at it, the color of the car is black. You'll be thinking in your head, no, there's an error somewhere. Something is wrong, right? This is not color that I wanted. This is not color that actually that I want. The person is telling you, no, this is your color. He said, no, there is an error somewhere, right? So now when, like I said, reiterating it again, when the actual condition hasn't met with the expected condition, there's a bug in it. So we'll look into these three. These three are like brothers, they are interconnected, right? They can't do with one another. So one actually error leads to defect and defect leads to failure, right? So let's look at them one after the other, right? So an error, also known as a mistake or a fault, right? An error, you can say it's also a mistake or a fault. It's a human action that produces an incorrect result. Take note of it. Error. You want to know what error is? It's a human action, also known as mistake. Yeah, I've made an error. There's an error there. You know that is a mistake or a fault somewhere, right? So it's a human action that produces an incorrect result. So when there is an error, right, that particular software would not be functioning as expected, right? So it is a deviation from the intended behavior of the software. So when we're expecting that the software should behave in a particular condition, and instead of behaving, let's say, when you hit the login button, right, you want to see the login field, right? And then when you hit the login button, you are seeing registration field. There is an error there. That particular software is not behaving as it is intended to behave, right? Error occur during various stages of software development lifecycle, right? Including requirement gathering. So requirement gathering is actually the, we will come into, so whatever I'm mentioning, I mean, it might sound as jargon, you might be familiar with it, but it's building on each other. Before we've been talking about agile and all this, but now we want to start building on software testing, right? So now I am mentioning, if you notice, I've been mentioning software development lifecycle. Don't worry, we'll come into software development lifecycle in great detail in our next lecture, right, or next class. So, like I said, error occur during various stages of software development lifecycle. This includes, right, requirement gathering. So, during requirement gathering, there could be an error. Let's say the BA has gone to the developer, to the stakeholders to elicit requirements, right? And I will take a simple scenario so that we all understand it. We know that you know the logo. Whenever you come to a particular website, you usually see the logo of that website, right? And then most websites, you will see their logo right on the top left-hand, corner or left-hand side of that particular website. So let's say, for example, the stakeholder or the product owner, whomever that owns that particular website, let's say you as a product owner, right? You've told your business analyst has come to you to elicit requirements for you to tell your business analyst what you want your website to look like, right? And you've told your business analyst or whoever that is gathering that requirement that you want your website, you want your logo to be at the middle, top middle of your website, right? So the business analyst wasn't paying attention or wasn't attentive enough, right? Didn't note that the fact that you said you want it to be at the top middle, right, of your website. The business analyst didn't take notice of it, and business analyst went away. And when he was like, oh yeah, when he's there documenting the requirement, he would be like, oh yeah, I'm sure every website they have their logo on the top, left-hand corner, and we'll just document it. The logo should be on the top left-hand corner, right? And then the developer has actually built it and put the logo at the top left-hand corner, right? When you as a tester, because you were not there during requirement gathering, right? Then you as a tester will now come and see, oh, the logo is at the top left-hand corner. You're looking at the acceptance criteria, right? The acceptance criteria is saying, yeah, the logo should be at the top left-hand corner. What would you do? You will pass. You will say, oh, it has passed, right? But when we now bring it to the owner of the website will say, no, this is not what I want. I want the logo to be at the middle, the top middle of the website. So what happened? That particular piece of work has failed because it hasn't met the expectation of the owner of the website. Do you get what I'm saying? So you as a tester, you are going with what is written in the requirements, right? The developer has already developed what is written in the requirements. And let's say during sprint planning, right? You've asked the developer, oh, where did you wrote that, the logo is, because obviously you all know, you also do testing during, you also test the requirements, basically. That's why you want to ensure that you understand it, you want to make sure that it makes sense, right, during sprint planning or sprint refinement, right? So you are not asking the developer, you are not asking the BA, is this where you want? And the BA said yes. Why? Because the BA has made an error. The BA has made a mistake. There is a fault because he wasn't paying attention. He wasn't attentive enough, and he didn't take note that the owner of the website wants it at the middle, right? So it's a mistake. That's why I'm saying that error can occur at different stages of software development lifecycle, including the requirement gathering. Because most of us think that error can just be maybe I as a developer, I as a tester didn't test it properly. No, you could test it properly based on I have had that incident when the actual requirement is wrong, right? The developer has done it with what the requirement is saying. I as a tester, I'm looking at the acceptance criteria and I'm going, yes, I've nailed it, I've tested it, I've tested every possible scenario, I've looked at all the scenario, I'm sure that this particular feature has passed. And then at the end of the day, when it has gone live, they are saying, no, this is not what we asked, right? So error can happen from, at the requirement gathering phase, right? It could also happen at the design phase, right? So when the requirement has been gathered, right? So some organization, what they do, they design it, they create a mock-up, right? Or some of them will create a wireframe, right? Just to design it to give a visual representation of how the website or the interface will look like. So if during the design phase, right, the maybe it's a UI UX person or the front end developers, right, didn't capture everything that is in the requirement, they made a mistake. It has happened as well, right? Then the developer sometimes they look at, people usually look at diagram or the visual representation, the light color. They look at it, they already know what it is. It's sort of going to read in between the line. They say, okay, I'm developing what I can see on the design, right? They go on the design, they develop exactly what they've seen on the design. Sometimes the tester will look at it and will be like, no, the design hasn't matched. I have seen a situation where I have a requirement, right, written by the BA. I have a mock-up or a wireframe, right, designed by the UI UX person, right? And then the developer has gone and developed what is on the design, right? Then when I'm testing, I've looked at the design, it's as much what the developer has done. But then again, I'm reading the requirements, it's different, right? And then again, I went back to the developer, look at what I'm saying, because at that moment, you don't know if you should raise a bug, or not, right? So I got to look at what I'm saying. The design is saying something else, and the requirement is saying something else. Which one is correct, right? So this is where you have the meeting, because obviously you as a QA, that's why we've got you to work in a team, right? We've got everyone to work in a team. You collaborate with the BA, you collaborate with the developer, because that's how it is in a place of work, right? So we call the BA, look, this is it. So after which we'll realize that the requirement is correct, right? The developer has mistakenly not read the requirement, but goes with what is on the mockup, right? Develop what is on the mockup, and then I am now testing. I've caught that there's a discrepancy between what is on the requirement and what is on the mockup, right? So what I did is report that, and then when we find the problem, the UI UX person has to go and correct that design, right? The developer will not have to redevelop what they have done, and then I've tested it, it has passed. Then I can now say yes, this particular software have passed and has met the expected condition, right? It could happen during code. So sometimes during coding, the design is correct, the requirement is correct, but during coding, the developers, they all usually make that mistake, right? So I will go into the errors that occur during coding when we go to software testing techniques, right? So that's why you apply certain technique to actually test your software to ensure that you catch those mistakes, those errors that developers usually make, right? So it could be from the code. The developer has not written the logic very well, right? Or let's say the developer is trying to say, this particular, let's take, for example, let me give you a real life example. Some software, right, that would take age 18 and above, right? So if you are less than 18, you won't be able to register with that particular software, right? And then the developer, instead of saying that when the developer is writing their logic, instead of saying that, it's from 18 and above, right? They could say from 18 and below, right? During their code. And then when you are testing it and you put, okay, what's your age? When your date of birth, and you put your date of birth to be above 18 and it's not taking it, right? What will happen? It's an error. It's a mistake from the developer. They can easily do it because what they use is less than or greater than, less than or equal to, or greater than and equal to. Sometimes they want to put less than and equal to, they are putting greater than and equal to. It's a problem, right? So that is why error can occur at coding level, right? Or even in the testing phase. Even in the testing phase, even you as a tester, it could mean certain things because sometimes you have different scenarios you want to test, you have different phases you want to go through, you are going through it, you are testing it. Sometimes there are certain conditions that you wouldn't test properly, right? You can make mistake. The error can come from you as a tester, right? So that's why you would test it properly, but error could still happen, right? So, but as a tester, you try to avoid any form of error, right? Because it's not good. We are there to dictate error. We are there to find error. So you shouldn't, as a tester, fall victim of allowing error to go through you. Because I know most often, when you go for an interview, some recruiter will tell me about a time you haven't caught an error and you allowed that to go to life, right? So anyways, let's move forward. So the next one, I'm sure you will have all understand what error is, and then we're going over defects, right? Are you still with me? I haven't heard your voice. Are we here?
Yes.
Are we following?
Yes.
Do we have any question, any concern at the moment?
I wanted to ask if a tester makes an error, who would detect that?
Good. Very good question. So, very good question. So when a tester makes an error or a mistake, right? So sometimes when we have done our own testing as a QA, right? Sometimes, most often, it goes through what is called UAT. Sometimes in some organization, the user, the tester does the UAT. Some organization have the PO doing the UAT, right? So this is when you get, sometimes you get the actual users to also test their particular software, right? So sometimes when it has escaped the QA, right, the quality assurance analyst, right, the actual users can actually pick that. It's not a death sentence, but it should minimize as much as possible. Ensure that you covered all the scenarios, you've given it a full test coverage to minimize too much errors or error that you should be able to detect. Because obviously no one is 100% accurate. There's no way you will say, oh, I've tested this application and it's error-free. No, it's not possible. But ensure that you've covered all the possible scenarios that you could cover. You've used the right testing techniques, right? And then if anything happens, sometimes the actual user will find this error and it will be corrected, right? So very good. Does that answer your question?
Yes, thank you.
Yes, so at least I know that you are all following. So I will continue and then we'll come back to another question, but in the meantime,
I have a question as well.
Okay, go ahead.
So you made mention of UI UX. Please, I want you to throw more light about what you mean by UI UX.
Okay, UI is the user interface. UI, user interface, and user experience, right? Okay. So the user interface is, Vincent did mention that, he went to Azure DevOps and he likes the interface. So the interface are those things that you are seeing, right? Those things that you are seeing. Most organizations, before a particular software is being develop, they would design it exactly the way they want it to be. The interface, they would design it, right? Exactly the way it is. Sometimes they could develop mock-up, sometimes it's wireframe, but wireframe is different from UI UX, right? So we'll have the low fidelity and the high fidelity, but this is me going into UI UX. So the US is the user experience. When a user is clicking one button and navigating into the next page, when they are entering, filling the form, what is the experience? Are they trying to click on a particular button and that button is disappearing? Right? And they are struggling to click on it, or they are clicking on a button they are meant to click once and it's not navigating them to the, to that chart, and they keep clicking and clicking and clicking on it. You might click it off for 4 to 5 times before that button will, navigate them. Or they are trying to load the page and it's taking ages. That is the experience. That experience is not good, right? So yeah, so you as a tester, when you click on a button, let's say you're clicking on checkout, you've added your, let's say you are in an e-commerce website, you've added all the product to your cart, right? And you're going to check out, you've clicked the checkout button and it's taking ages to load, right? That experience is not good. So you as a tester, when you see that, you also have to notify the developer, raise it as a bug, right? Okay, we'll move on and then we'll answer your question when we are done. So we'll still have a few more to go through. The next one we want to go into, we've mentioned what error is. I mean, reiterate it, is a mistake or a fault. It's a human action that produce an incorrect result, right? So the next one is defects. Defects. I know by the end of this slide, you'll be asking what is the difference between defects, error, and failure. But I believe that before I go through all of you should be able to note down the difference, right? So a defect also referred to as a bug or an issue, right? Is a manifestation of an error in a software, right? So when there is an error, it's a mistake, someone has made a mistake. The manifestation of that error is known as a defect, which we can also call bug. I keep mentioning bug, right? So a defect, also referred to as a bug or an issue, is a manifestation of an error in the software. When an error occurs, it may result in one or more defects in the code, right? Defects are identified during the testing process when the actual behavior of the software deviates from the expected behavior as defined in the requirements. Defect can encompass coding error, logic mistake. I did mention of code and logic. Sometimes developers write loads of logic. You will be writing your logic when you start your computer test, right? So a developer might make a mistake, make a coding mistake. So all this will lead to an error in the software, right? Note the difference. First, there could be a mistake, which is an error, and it's a human action that produces an incorrect result, right? So when this error is being manifested, it becomes a defect, right? And defects are also known as bug or an issue. So I was talking about a failure, right? So a failure occurs when a defect causes the software to behave in a way that is inconsistent with its specific requirements. In other words, a failure is the observable or incorrect behavior of a software during its execution, right? So when you are actually trying to execute your software and you observe an incorrect behavior, right, it's a failure. So failures are the outcome of defects, and they are identified when the software does not meet the user expectation or produce incorrect results. Failure can occur in various situations, including during testing or in the live production environments. So it could be on the staging environment, it could be on the live environment, it could be on the testing environment. Is that clear? Yeah, is that clear? I want us to get this three. Am I getting a yes? Or should I come again? Can someone mute? I will hear.
Yeah, we're here.
Yeah, is that correct?
I'm here.
Error, defects, and failure.
Yeah, go on.
Yes. Okay. So now we want to talk about the relationship between these terms, right? So as you can see here on the slide, we have an error. An error or mistake will lead to defects, right? An error or a mistake leads to a defect, which can cause an observable failure, right? So when an error occurs, it leads to defects, and these defects can lead to failure, right? Error, a mistake made by a human during the development process, right? That's the definition in a nutshell. The defects, the manifestation of an error in a code or software. Failure, the observable deviation from the expected behavior during the execution of the software. Right? So in testing phases, the goal is to detect and document defects because the software, so before the software is released to users, right? So you need to detect and document any defects before it's being released to the users, right? You need to prevent failure in the live environment, right? And how do you do this? You do it by finding and fixing defects early in the development process, right? So once the developer has done the development, you as a tester is testing it, you need to actually detect those errors or those defects, fix them as early as possible, right? So that to minimize the likelihood of failure in the production environment, right? So moving over to the next slide. So we have incorrect software can cause harm, right? So as we all know, let's say, for example, we have a software that you can use to, because obviously, you know that the plane, is you use the software that is embedded in it to actually pilot it. And when there is a defect, right, or a failure to that software, what happens? The plane tends to lose control, right? So it can cause harm to people. Let's say a particular software is, you have a product and the information on that particular software, okay, you have a software that you use to actually sell some products, right? And then the developer is adding information on that product during the development process. And the developer has said that, instead of saying that this particular product is not for consumption, right? The developer has said, instead of saying this product is not for consumption, and the developer is saying, yeah, this particular product is for consumption, right? And someone actually bought it and was like, okay, yeah, I can drink it, right? And the person drank it and actually it's not for consumption, right? What happens? It could cause harm to the person, right? So the same as train, medical equipment, for example, medical equipment, right? So if, as you all know, we check our blood pressure, we check our heart rate, we check our temperature with, software that is embedded in a device, right? So let's say that software is faulty, right? And instead of reading the actual blood pressure, the software is giving incorrect blood pressure. It could cause harm. It could cause harm to people. So like I've said, incorrect software can cause, it can cause harm to people, right? So it can also cause harm to companies, right? It can cause incorrect billing. Let's say, for example, a billing company, right? So instead of billing the right amount, for example, their software is not good. Instead of billing £100, they are billing £10. So it's causing lose of, the company is losing money. The company would lose money, right? Or for example, it's causing higher amount. Let's say your electric company, instead of charging you or billing you £50, they are billing 150 or 200, right? Customer will lose faith, right, in them. You want to go with another provider. So it causes harm to people. It causes harm to people. Incorrect software also causes harm to companies. It can damage companies' reputation as well. So environment, it can also cause harm to environment, right? Let's say you have a software that monitors your plants, for example, right? And this software start malfunctioning and start releasing harmful, gas to the environment, or releasing some chemical or radiation into the environment or into the atmosphere, right? It causes harm to the environment, degrades the environment, and depletes the ozone layer. So these softwares can actually cause harm to people. It can cause harm to company. It can cause harm to company. It can also cause harm to environments, to our environment. So these are the three major categories that incorrect software can cause harm to, right? So we'll go to the next slide, which says, when do we stop testing? Very important question. You are testing, right? And when do you stop testing? Because it's important. You know when to stop testing, right? So if you look at my slide, it says exhaustive testing of complex system is not possible. So if exhaustive testing of complex system is not possible, what do you do? Do you keep testing and testing and testing and testing? No. If every testing had been run, testing would have gone on for long and the product will not be released to the customer, right? Let's say you are testing a particular software or a particular complex software that is complex, and you keep testing every, parts, every scenarios, and you keep thinking of more and more things to test, you won't finish testing. So exhaustive testing is not possible. What you will do is use the right testing technique, all right? Ensure you give it a very good coverage. Ensure you've, covered all the acceptance criteria. You've tested every possible scenario that makes sense, right? You would stop. That's when to stop, because exhaustive testing is not possible, right? And then there are so many other factors that can contribute to it, So those factors could be budgets, it could be time, it could be capacity, it could be appetite of the company. Then you have to stop testing, right? So the next one is testing and risk. Risk in software development increase with system complexity, right? Once the system is complex, the risk increase. I've been in a project where I have to test very complex softwares. It's very difficult to navigate, and the risk is high, right? But then you have your acceptance criteria, you have your requirement to guide you, right? You have to choose the appropriate testing technique to use, and that will help you test that particular software properly, ensure that you reduce the risk. Yeah. So necessitating more extensive testing in proportion to the level of risk, as failure probability and impact are high in complex testing. So I will take that again. So risk in software development increase with system complexity, right? Necessitating more extensive testing in proportion to the level of risk, as failure probability and impact are high in complex system. So when the risk, right, is high, you also need to test that particular feature or software more effectively, right, to ensure that the risk is being reduced, right? Because as I've mentioned earlier, once it's a complex system, the risk will be high. So you ensure you test properly, all right, to reduce those risks, right? So testing and quality, right? So like drawing it back to when do we stop testing? So once you've tested all these areas, you've given it an extensive testing and ensure you've reduced the risk, right? You probably should stop testing, right? So testing and quality. Quality in software is often tied to meeting users' requirements. So testing plays a crucial role in identifying and reporting both functional and non-functional issues, contributing to enhanced system quality by facilitating defect removal, right? So once you've done all these things, you've tested properly, right? And you've ensured that the quality of the software has met users' expectations. Then what do? You probably stop testing, right? So deciding when enough is enough is another one that will help you to decide when to stop testing. You need to determining the appropriate amount of testing involve prioritization based on the system's most crucial aspects, focusing on essential functions and addressing significant risk. I've tested a particular software there. Yeah, so we're testing it. There are some few bugs, some cosmetics issues that we have on the software, but we've tested all the logics, we've tested all the important functionality, right? And then the due date, the delivery date is very close, right? We've gotten to the day that application should go live, right? And then we've reported to the stakeholder, this is where we are, this is what is still remaining. I've raised my balls, I've documented it, I've sent a report, right? And then they looked at it and they were like, okay, 1, 2, 3, it's fine, we can go live. It's not a showstopper. 2, 4, we need to fix it before we'll go live. So they chose the one they want to fix. We'll assess it, we'll look at the severity, right? And the ones that they didn't choose is not, it wouldn't cause any major issue, wouldn't stop users from actually using the website. They say, okay, yeah, we can do with that one. Let's fix the other one. We'll fix it, we'll test that it went live. And then after it has gone live, in the next sprint, we now have time to actually work on the other ones and then fix it. So those are the factors that you need to use to determine when to actually stop testing, right? Defining quality of a software is challenging, right? It's very, very, very challenging. So that's why you need to test to ensure that you meet the user requirements, right? And every user requirement is being met, and any crucial functionality is tested properly, and it's risk-free. There's no risk on it. So we'll move to the next one, which is general testing principle, right? General testing principle. So general testing principle. we'll quickly go through the general testing principle. The first one we'll have is testing shows presence of defects, right? Testing shows presence of defects, right? So the International Software Testing Qualification Board, which is ISTQB, let me mention this now. So as a tester, you can't have this certification, you can sit for it, right? It's good, it's important. It wouldn't stop you from getting a job, right? It wouldn't stop you from getting a job if you don't get this ISTQB, right? But if you can do it, it's important you do it, right? So what was I saying? So the general testing principle, right? So this seven testing principle is outlined by International Software Testing Qualification Board, ISTQB, right? So these principles are fundamental concepts that contribute to effective and efficient testing process, right? And they include testing shows presence of defects, right? Testing is conducted to identify defects or error in the software, as you know, right? The goal is not to prove that software is error-free, but to uncover issues that need to be addressed, right? I said testing show presence of defects. So the goal of this, testing to show the presence of defects is not to prove that the software is error-free. Like I said, error fallacy, saying that your software has got no error is a false, right? Every software has got errors, right? So the next one is exhaustive testing. It's impossible. I've mentioned that before. You see how they are building on each other. There's no way you can say you've tested every possible scenario. You've tested everything, right? It's impossible. Say you are given a software to test, and they told you that only people that can log into that website is people who are from 18 to 100 years, for example. Is it possible you can test with 18 years, you test with 19 years, you test with 20, you test with 21, you test with 22, you test with 23, up to 100? It's not possible. You will spend all day, testing, and at the end of the day, you might not even get 100 to see if actually 100 users. So exhaustive testing is impossible. It is impossible to test all possible input combination, like I mentioned, and scenario exhaustively due to the resources constraint, time limitation, and complexity of modern softwares, right? Testing efforts should be focused on the areas of high risk and priority. Like I said before, I use an illustration. I've listed all the things that are not working. We'll merge, we'll look at it, we'll prioritize it, we'll check the risk, right? We'll check the severity of those ones. We'll choose the one that has high risk and of high priority, and we decided to fix that one, and then we went live, right? So the third one is early testing, right? Early testing. Testing activities should start early in the software development lifecycle. Detecting and fixing defects at early stage is more cost effective than addressing them later, right? Like I said before, when you are fixing software in retrospective, it costs more than when you detect the error early and fix it early, right? Early testing help prevent the propagations of defects through the development lifecycle. So you don't see when you detect it early, it doesn't go to UAT, it doesn't go to live. You test it, you detect it, and then the developer fix it, you test it, and then everything is fine, right? So the fourth one is defect clustering. Defect clustering. So I'm mentioning it over and over again because these are some of the buzzwords. These are some of the things right? You need to know. So in a given system, a small number of modes or functionality typically contain the majority of the defects. So a particular functionality might contain most of the defects, right? It might contain most of the defects. So focusing testing efforts on this high risk area can yield a more effective outcome. So when you look at those areas that you think that bugs, right, errors will be, so you focus on those areas, right, and ensure you test it properly, right? So that is what defect cluster. Defect can cluster. It can stay around a particular area or a particular functionality. Take for example, right? You have a system that receive logs, right, of whatever users are doing, right? And then every time there's error, you keep having error there. Sometimes it's not picking up what the user has done. So you need to focus on those areas and test it properly because there could be loads and loads of bug clustered or defect clustered around that area, right? So the next testing principle is pesticide paradox. pesticide paradox, right? What is pesticide paradox? What does it mean? If the same set of test case is repeated over time, right, the effectiveness of finding a new defect diminish, right? To combat this, the test case need to evolve continually, incorporating new scenarios and test conditions. Pesticide paradox. What does pesticide paradox mean? Let me explain it again. So when you are using the same test case to test registration button or registration functionality, right? So during the first time you've tested that with a particular test case, you caught bugs, right? You reported so many bugs or so many defects, it was fixed, right? So now when you come back when it was fixed and you are using the same test case to test that particular functionality again, the chances of finding bugs keep diminishing. Let's say the first one you run it, you got like three bugs, right? Or three defects, it was fixed. You run it the second time, the same particular test case, right? You got one bug, it was fixed. When you use that particular one again to test it, you wouldn't see any bug. And if you keep using it to test it, you might likely not see any bug, right? So what pesticide paradox is saying that for you to actually test that particular, you need to look at that test case again, right? You need to make it evolve. You need to incorporate new scenarios. If not, you will never see any bug, right? So that is it with pesticide paradox. The next one is testing and is context dependent. What does that mean? Testing is context dependent. I mean, from the word testing is context dependent, you can actually deduce what it means. So testing approach and techniques should be adopted based on the context of the project. Right? So when you have a particular project, you have a particular software that you are testing, the way or the technique or the approach you should adopt or you should use to test that particular software should be based on that project. It should be within the context of that project, right? This can include requirements, right? Technology, development methodology, right? There is no one size fits all solution to test a particular software, right? All testing practice must be tailored to a specific project. Right? So when you have a particular project, the way you test, let's say I'm testing a website, the way I test a website will be quite different from the way I test a mobile app. Let's say I'm testing a tool that collects sets of data. The way I test it will be different from the way I test that particular. Let's say I'm having an e-commerce website. The way I test an e-commerce website will be different from the way I test a medical or hospital website or hospital software. Right? So it depends on the project. It's context dependence. And then the last but not the least is absence of error fallacy. I've been saying this over and over again. So we've met its absence of error fallacy. So the absence of dictated defect does not necessarily indicate that the software is error-free. Let's say you've tested a software and then you didn't find a bug. That doesn't mean that that software doesn't have an error, right? It might have an error, but you haven't actually caught it, or the risk is low, right? Testing can only provide information about the presence of defaults, not the absence, right? Testing can only provide information about the presence of defects, not their absence. So when you are testing and then what you are testing, you can find defects, but you can't say, oh, we have tested and there's no defect there, right? So quality is a borderline concept that goes beyond just defect dictation. This principle provides a foundation of effective testing strategy and help testing professionals make informed decisions throughout the software development lifecycle. They emphasized the importance of early testing, risk-based prioritization, and adaptability in testing process, right? In a nutshell, error fallacy, one of the principle of software testing, right, says absence of error is fallacy. When you are testing a software and you haven't detected any bug or any error, that doesn't mean that that website is free of defect. In a nutshell, that's what it means, right? So we'll go to the next one, go to the next slide, which is fundamental test process. Fundamental test process. So fundamental test process is the first one that we have. The fundamental test process as defined by the I'm still quoting the International Software Testing Qualification Board, ISTQB, right? Comprises a set of activities and tasks that guide the testing efforts throughout the software development lifecycle. The process is iterative and adaptable to different development methodologies. The key phase of the fundamental test process are as follows. One is test plan and control, right? In this phase, the testing team established the overall strategy. So in the course of this internship, you will be developing a test plan documentation, test plan and test strategy documentation. Don't worry, we'll walk you through on how to do that. You can't get into an organization and they will ask you to develop our test plan for us. So he will develop it, will walk you through how to do that, right? So don't worry about it, you will do that. So as I was saying, right, test plan involved defining the scope, right? It involved defining the scope, objective. So this, you will now mention the scope where, okay, our software will cover the functional and non-functional parts, right? So you will state the scope, you state the objective while you are testing, you state the resources that you'll be using, right? It could be a laptop, it could be Chrome driver, it could not Chrome driver, it could be your browser, your internet, those are your resources. Schedule, right? When you are testing who and who, who is your manager, who are the QAs, right? When you go into test plan documentation and how to develop it, you will do it yourself and you'll be proud of yourself, right? So, and the deliverables, right? So the deliverables could be the piece of software at the end of the day or your documentation, right? So test control involve monitoring and adjusting the testing activity to ensure they align with the project goals, right? So I've mentioned the test plan and then the test control. I say that the test plan, right, involve defining the scope, objective, resources, schedule, and deliverables. Why the test control involve monitoring and adjusting the test activity to ensure they align with the project goals, right? So the next one I have is test analysis and design. So this phase involves analyzing the tests, right, which include requirements, specification, the design documentation to identify test condition. So test designs can create detailed test cases, right? So when you have designed your test, it helps you to create detailed test cases, detailed test scripts, and then the test dates based on this condition, right? The focus is on designing tests that covers a range of scenarios and conditions, including positive and negative. So when I was giving you an instance, right, I told you, okay, once you've tested your negative, you also test your positive. So test analysis and design, you analyze your requirements, and then you design your test by creating test case and test scripts, right? Get the point. Test analysis, analyze your requirement, analyze the specification, right? Then the design, you design your test case and you design your test scripts, right? So the next one is evaluation of exits criteria and reporting, right? No. Okay, so before we go to evaluation of exit criteria and reporting, we need to talk about test implementation and execution, right? Test implementation and execution. So just note it, right? So the first one, you go through test planning and control. The second one, you go through the test analysis and design. So the third one, you go through the test implementation and execution. Testers implement the design test case, configure the test environment, right? Prepare test data, right? So I mentioned test implements. Testers, you as a tester, you will implement the design test case, right? You will configure your test environment and prepare your test data. Sometimes you have someone that is doing that for you. Sometimes you have to do it yourself, right? The actual execution of test case takes place and the testing team observes and records results. This phase includes both manual and automated test execution and aim to identify defects in the software, right? So you implement your test case, right? Configure your environment and then execute your results. You take note of the test results, you record it, you take screenshots, right? And then we'll move over to the next stage, which is execution of exit criteria and reports, right? So execution of exit criteria and report. The testing team assess whether the exit criteria defined in the test plan phase are met, right? So once you are done testing, you will now look at if your exit criteria is being met. So during when you develop your test plan, you go through what the exit criteria is and all that. We shall go into that in great detail, right? And the aim of this thing is just to get you to understand the fundamental, what you are doing, because it's not just testing. There are other things you actually need to know before you jump into testing, right? So, yes. So, so the evaluation of exit criteria and reporting, right? So let's talk about the reporting side of it. So testers will prepare a summary report which provide information about the test activity, test results, and any open issue. When you go to Azure DevOps, when you go to your test plan, right? You see where all this report is, right? Sometimes you have to do it. If you're not using Azure DevOps, you have to do it yourself. But if you're using this test management tool, it provides you that. You take screenshot of it, record it. You can present it during, your demo. You present it to your stakeholders, show them how many test cases has been run, how many, is still in progress, and all that, right? So, and then the last one is the test closure activity. After testing is completed, the testing team perform closure activity, including gathering data for metrics, conducting a review of testing process, and archiving softwares. Test closure ensure that all the necessary documents is completed and the lesson learned are captured for future improvements. It's important to know that these phases are not strictly linear, right? It's not a mosaic, all these phases that some organization will bypass it. They don't want to go into the nitty-gritty of it, right? And the process is often iterative. Change in requirements, right, code or other project factor may lead to revisiting area phase. Additionally, the fundamental test process is adaptable and can integrate into various software development methodology, including the agile and waterfall, right? So we'll go to the next slide. So the next slide is different roles in software testing, right? Different roles in software testing. So different roles in software testing, like I said, you've heard me use quality assurance engineer, you've heard me use test analyst, I've mentioned UAT tester, right? I've mentioned manual testing. So you as a tester, you can be called a quality assurance engineer, right? So when you are looking for a job, you can either type quality assurance engineer, that's your role, that's who you are. You are a test analyst. You could be a manual tester if you're doing just manual testing. You could be called QA test analyst. You could be a UAT tester. You could also be a functional tester, right? To be a functional tester. You could be an agile tester. So sometimes they call it agile tester. It could be an automation tester, right? These are different roles when it comes to software testing, right? And then we'll go to the next one. So which are software testing skills? What are the skills you need? You need analytical skills, right? You need to analyze, your requirements. You need to ensure that they are correct and they make sense, right? So, you need to understand complex system, right? You need to understand complex system. You need to be able to identify even the small, you need to identify potential issues and diverse effective testing strategy to actually test that, right? So that is your analytical skills speaking for you, right? Which I believe all of you have, right? You need to attention to detail. Attention to detail is very, very, very important because your own is to dictate what is not working well. So you need attention to detail. You need to ensure that everything you've thoroughly tested, or even the smallest, you've thoroughly tested and identified even the smallest defects that could impact user experience, right? So the next one is problem-solving skills. You need a problem-solving skills. Testers encounter various challenges during testing, and the ability to analyze problem and diverse practical solution is crucial. So you need to be able to solve problem, right? That makes you a good tester. Because why I'm illustrating and mentioning this is that sometimes you go for an interview and they will ask you, what are your skills? What are the skills that make you stand out? Right? You mentioned these things. You mentioned that you have, analytical skills. You have you have great attention to detail. You're a problem solver. Okay? This will, help you put you forward. Right? Communication skills. Communication skills is very important. Like as I mentioned, you're not working alone. You need to be able to communicate whatever findings that you've got, right, to stakeholders, to your developers, to your BAs. So it's very important to have communication skills. Very good one at that. Then the next one, I'll go on the next one, which is technical proficiency, right? You need to be technical, right? You need to be able to, obviously, for an automated tester, you need to be able to understand a programming language. You need to be able to write your code. You need to be able to write your SQL code, to get where to query database and all that, right? You need to be able to navigate the website and do some other basic things that you'll be required as a tester. Understanding of development process. You need to understand how software is being developed. You need to understand when to start testing. You need to understand when the developer has done what you need to do. You need to understand bug process, which are the reason why we're here, and we'll go into that, right? So time management, you need to be able to manage your time because sometimes software will be going live, so you need to be able to test it within the allocated time. Not that you will be in a hurry and say, yeah, that software that hasn't passed, that hasn't met its expected condition has met the expected condition because you need to meet up with the time. No, you're testing, but once you're testing it, you need to understand like this is the time that you don't want to be on a particular website for ages and you keep testing and never finish. So you need to know how to manage your time effectively. And testing technique, you need to understand testing technique. We'll go through this in one of our class. We'll go through testing technique. You need to understand testing technique, different kind of testing technique, and when to apply it. They are very, very, very important that you understand them and when to apply it. And we'll go into that in great detail. And that brings us to the last slide, which is thank you for listening. Any question? There's question time, so you can raise your hand up and then ask as many questions as you want. Any question?
No, I don't have any question.
Okay. Does anyone have any question? Is it clear?
Yeah, it's clear, but just need to make sure I understand what you said regarding the testing rule. So after this class, so are you saying we can, as a tester, we can take or answer any of the rules you just mentioned on the screen? You can say, oh, you are a test engineer or a test analyst, whatever you feel like to call yourself. Is that what you mean?
Yes. So you are all these things. You can either be a test analyst, a UAT tester, an agile tester, an automated tester, a manual tester, any of all this, a test analyst, QA, any of all these things. That's what you are.
Okay.
That's right.
And also, when you are looking for jobs, you can search it like you guys do the same thing. If you search a job as a automation tester or manual, it's the same role. So it's just so that you guys will be aware there are different roles. It's not just where you go on Indeed or somewhere you just type in software tester. No, you can type in QA engineer. These are different names that certain companies use this. So you don't limit yourself to only software tester when you are looking for a job in Indeed. So that's
the rule on it make it as if you need to choose a particular role. But now I understand, like they can call it anything in the job short.
Exactly. Yeah.
That's right. Yeah. Yeah. So yeah, in the absence of no other question, we'll all join the main room